Docker is a container orchestration tool and is a segment leader. If you are building microservices using Docker, there are great chances that multiple containers shall talk to each other. As the application is segregated among multiple images, managing and debugging become cumbersome and tedious in development and in production as well. This is where Docker Compose comes handy. Docker Toolbox comes equipped with Docker Compose. Docker Compose lets build, spin up and spin down multiple containers at once. Here we are going to use some code to build Docker images and spin them to create a development environment that looks very close to the production. So let's start with the regular virtual machine stuff and how it is different from Docker engine, Docker environment, Docker ecosystem as per se. So when we boot up a virtual machine, we boot up a virtual machine using an image, and this virtual machine is being managed by a hypervisor. This hypervisor talks to operating system, which is our host operating system. This host operating system talks to the bare metal, which is our machine. So whenever we are booting a virtual machine, this virtual machine boots up an operating system in the same manner we boot a machine. So it keeps its own operating system. Even if we have two virtual machines booting up from one image, we are going to get two virtual copies of this guest OS running on top of hypervisor. Hence it is a bit bulky on the side of consumptions of resources. On the other hand, containers, they are easy to go because Docker engine has got CRI, which is a container runtime interface, and this is how it manages the containers. So if we need to talk to Docker engine, we do it using Docker CLI. So if we need to present anything to Docker engine, we present it to Docker CLI, and Docker CLI then talks to Docker engine, and then Docker engine talks to the containers or images or the infrastructure or the ecosystem which Docker engine has. So we have images, we build images, we keep them in either container repository or maybe on our machine, and we boot those images, we spin those images, and we call them containers. So this is a superficial a view of like how Docker is different from the regular hypervisor stuff. So now let's start with running a few Docker commands which we should know. Let's spin some Docker containers, and then we'll start with the code. If we want to talk to Docker engine, then we need to talk to Docker CLI. Let's start with a few commands which we use very frequently. One is Docker image. It should return us images which are there on our system. Next would be Docker PS. It returns the running containers. Since we do not have any of them for now, what we are going to do here is we are going to Docker run a container. So Docker space run space the name of the image. So we run this image to a container. Docker run hello world. What is going to happen next is it is going to pull it from the container repository, which is Docker Hub in our case, and then it is going to spin it up. It pulled this one, and then it made a spin. So this is what this text is what we get. from the Docker hello world. If we run this hello world image, so if we go to Docker images, we shall see one image, but there would be no containers running. But when you issue docker ps-a, you should see one which made an exit 44 seconds ago. It made an exit because there was nothing which is making it stick to the terminal, or maybe it is making it running forever. So for this, like if we want to interact with a Docker image like this, a Docker container like this, what we do is we run that in an interactive mode. So we'll open the standard input using -i, and we'll open a terminal using -t on Alpine. Alpine is the slimmest, I must say, the slimmest Linux Docker image by far on Docker Hub. And the next sh is what I'm going to use as a command to Alpine. So what it is going to do is it is going to grab Alpine from Docker Hub. It is going to pull this image to the local system, and then it is going to open it, where it will open a standard input for us, and it is going to greet us with a sudo terminal, and this is going to happen on shell which is coming out of Alpine. That's it. So as soon as this goes off, okay, it is just 3 MBs. As soon as it goes off, we are greeted with one command prompt. If I enter ls, I am going to see what is coming from Alpine. If I'll issue uname -a, it will give us whatsoever the version of Linux it is working on. And now if I go to docker ps, we shall see one Alpine working. So this kind of scratches the surface of those run and image and containers thing. We are going to see those things working practically in depth, and we shall be starting with the code which we have in our repository in just a minute. But just to get you a refresher out of what Docker images, Docker ps and Docker ps-a and whatsoever those lean commands do, we had this intro. So yeah, now quickly just jump to the code part. We'll see you in a minute there with the code. Thank you. Before we jump on to the code and the regular Docker stuff, let's talk about the application which we have as of today. So this is what has been done by now. So MongoDB and React is used along with Node.js to create the whole architecture. Also, there is a queue. So this API server is a Node.js Express application which acts as a publisher as well. It drops some messages on the messaging queue, and the polling module is intended to read those messages, do something with those messages, and update the MongoDB. So the polling module is basically writing to MongoDB and reading from it as well. API server is only reading from the MongoDB. The front end is written in React. So those are the kind of 5 components here as of now. We shall be introducing another one, at a later point of time, but more on that later. Now we shall be creating images out of those coded components, that is the front end, API server, and the polling module. But for the queuing thing, we shall be using a Docker image of software mill elastic MQ. So this thing simulates SQS in memory, and it works really as one of the SQS which is working locally. Apart from this, the polling module is using SQS consumer by BBC. So it is another good library or node module which helps us polling SQS, and it is there. So we have used it right away rather than writing it all from scratch. So the code is there in the repository. We shall be making some changes in the code. We shall be creating some Docker files, and we are going to containerize everything, because this is our development environment. We shall not be serving from a local laptop or a desktop. We need to serve it from some real maybe bare metal server, or maybe from somewhere from the cloud. So for this we need to containerize it. Now again, there is one component which is not visible as of now, but we shall talk about it at a later point of time, and that is a very vital component which we should have when we are actually creating a production grade development environment. So more on that in a minute. All right, so let's get started with the code. This is the URL to the repository. If you feel like, you can check out the code which we shall be doing in a few minutes from now. So I'd already checked it out, and I'll just show you where you can find the concerned code. So there are so many samples in here, but we are concerned about one which is in the Docker directory, and in Docker directory you will see there is this folder called Docker Compose Dev Sample. So I'll quickly change the directory to here cd, and I'll just open this in Visual Studio Code. So yeah, those are the three components which we talked about earlier. So this is the API server, this is the front end which is in React, and this is again the SQS poller. So what we are going to do next is, before we build Docker files for those three components, we shall use the Docker images out of the box for software mill, elastic MQ, and Mongo. So let me quickly bring up the terminal, which is this, and we'll get started with it. Okay, so let me increase the size of the font. Okay, so we'll issue the command docker images, and it shall return us nothing because we do not have any images in the local machine, on the local machine. Now we shall be using the elastic MQ out of the box from the repository, and I need to run it. So I will just issue this command docker run it, and I need to open a port which is 9324 on the outer world localhost, and 9324 on the side of the image. So it will expose 9324, which is written after the colon, from the container to 9324 on the local host, and this shall run the image. Now, since we do not have anything on our local machine, it is going to download this, and then it is going to spin the container. How do we see a container getting spinned? Let's open another terminal, and here Docker PS. So we do not have any processes running, any containers spinned up, so we cannot see anything. As soon as this image gets downloaded and spinned up successfully, we shall see a few details here along with the container ID, which is a vital detail which we need to do whatever we want to do with that container. Jumping back here, it has successfully pulled down, and our Elastic MQ is now running. So we must see something here in Docker PS. Okay, good. So you can see that there are a few things here, but let's emphasize on the ports part, which is 9324 of the local is exposed to 9324 of localhost, and this container ID. So we can use this container ID to see, let's say we want to see logs, then we can see this by using the initial 4 characters of the container ID along with the command. So this is how we can do a few things with the container ID, and hence it is vital. It actually gives us a handle to do whatever we want to do with the running container. Next, we are going to boot MongoDB in the same fashion. Okay, so Docker run, and I need to open a port which is the default port of MongoDB, and now I'll use another flag which is -v. -v is used to mount the volume. So I am going to mount data db to Mongo data, and the name of the image, which is Mongo, and that's it. It is going to do the same thing. It is going to pull the image and it is going to run this, and then when it is done, we shall be able to see this in Docker PS. So it is kind of a bit bigger image, so let it get completed. I shall be back when it is done. Okay, so we have another container running, and let's go back to Docker PS and see what is happening here. Okay, good. We have 2 of them with 2 container IDs. That means there are 2 containers running, and in the status you can see it is up since last 13 seconds, and this thing is up for since last 3 minutes, and those are the ports which are opened. Apart from this, what else you can see is the command which is being issued to that Docker container when it is spinned up. So this is pretty much a bit of refresher on how we run a Docker image out of the box and spin it to a container. Now next, what we are going to do is we are going to write our own Docker files. We are going to write our own images, and we shall be using those images to spin some more containers which are going to interact with those containers which we have already spinned up. So we'll start with Docker image in just a minute, but some theory before that. Before we start creating our own Docker images, let's talk about how things happen in real world. So there is something known as a container repository. In that repository, what we do is like we keep our images. So let's say we are done with development, we are done with creating our own image. So finally what we do is we push that image to that container repository. Now this is needed when we do something with that image, or when we want to spin that image. So we need it on our machine. So on our machine also we can keep images. So we pull that image down first, and then we issue a few commands on that image using Docker CLI. We present this image to Docker CLI with a few more options, and then we see those images working as containers. And this is how it actually happens. So this is what we have done lately. Now what we are going to do next is we are going to use Dockerfiles to build our own images. So Dockerfile is a set of instructions which can be understood by the Docker CLI. So we create a Dockerfile and we present this Dockerfile to the Docker CLI. What happens next is the Docker CLI runs this Dockerfile in a context. So the context part is precisely the root of the Dockerfile where we want to execute our Dockerfile instructions. So we execute a Dockerfile against a context. So we have already written a Dockerfile with a few instructions in it, and this Dockerfile is not alone there. It has got company. It has got more files in the context, in the directory. So we pick this Dockerfile, we present it to the Docker CLI, and we issue commands like docker build, and this gives us an image. So we can do whatever we want to do with that image. If we want to push it to a repository, we can actually push it right away. Or if this Docker build is happening using the CI/CD environment, so that environment is entitled to push this image to the repository. So this is how it happens on a vague level. So what we are going to do next is we are going to use Dockerfile to build our own Docker images in the example for the code which we have already done. So yeah, what we are going to do next is we are going to jump to the Dockerfile stuff. So we are going to create one file in this directory where our API server lies. Let's name this file Dockerfile. You may have any name of this file. For this file, it could be like 123.xyz is also absolutely fine. The name Dockerfile is just not the convention, but it is the default file which Docker picks up when we issue a build command. Next is we shall start writing some instructions in this Docker file. First thing we are going to write here is from, and the IntelliSense of Visual Studio Code speaks from base image. So we are going to take node Alpine as the base image. So node is the name of the image and Alpine is the version. So this is an image which is tagged as node Alpine. When we shall be building our own images, we shall also be tagging them as well. Next, we are going to change workdir to app. That means take node Alpine and create and change the directory to /app. Now what I'm going to do is a bit tricky, but it is needed as well, and it should be done in that way. That is the recommended way. So from the current folder, from the current context, I must say, just pick this one package.json file and copy it to the working directory. When I say /, that is the destination, and the destination here is the workdir. Work directory is where our base image is now hypothetically is. So what copy is going to do again is it is going to copy this package.json to this directory, which is our current directory, which is our working directory. Why I'm going to do this? Just in a minute I'm going to do it. I'm going to reveal it, but before this, let me complete with the other commands as well, other instructions as well. So I'm going to run now a command which is npm install. So whenever we create a node module, if we have package.json and if the package.json contains the name of the modules which are needed, so here you can see that those things are needed, those are the dependencies. So what this is going to do is it is going to install the node modules here. This is precisely it is going to do for us. Next is I'm going to copy all the files from the current directory to the current directory at the destination, that is our workdir once again, which is /app. Finally, I want to run my image with the command npm run start. So this is finally the command which is going to run when I am done with all my instructions on that image. When I'm done doing this, what Docker CLI is going to do, it is going to register this command as a running command which actually spins up the image. It could be anything. It could be like, if you want to cmd ls, that is perfectly fine. It could be anything. But what's going to happen here, if it is not a command which stays there, what's going to happen here is it will just show the name of the directories and it will go away. It will just sleep. It will just die. So we should have a command in those kind of things. When we are actually serving, we should have it here, a command which actually sticks your image and keep it running. So don't need cmd-ls. Okay, we need this command. Yeah, and this works for us. Okay, now the curiosity about this, whenever we create an instruction set as a Dockerfile, what exactly happens is it gets built and served to us as an image in hypothetically the inverted way. Let's visualize this Dockerfile happening in a stack. What happens here is every command we give it to a Dockerfile, it happens as a stack, as a layer on a stack, I must say. So first thing, we should the command from node alpine, which is our base image. What does this do is it pulls node alpine. Next, we change the directory to /app. Then we are copying just one file, package.json, to the current work dir, which is /app. Then running a command which is npm install. So by this time, what exactly is happening with our base image is we have just one directory /app in the image, and we have copied just one file. So hypothetically, visualizing it, we just have one file there which is /app/package.json, and on that we are running npm install. Where does this npm come from? Because we are using the base image node alpine, which already has got the tool set, the tool chain, which we need to have it there to maybe build or maybe do whatsoever we want to do with our files in that Docker image, and hence we have this npm command there. So we are running npm install. Then the next thing what we are doing is we are copying every file from our current directory, which is the context, to the image, and then we are registering this command with the image. Like whenever the image is issued a run command, it is going to run with this. Oh, what has changed? Precisely nothing. It is all the same what we have written, but we need to go through this because there is a layered approach which has been used by Docker whenever a Docker build is given. You see the first command, node alpine, from node alpine. So this is the base image. So Docker is not going to pull this image every time whenever we are issuing the command Docker build, and that is because nothing has changed there. Next, work dir /app. If nothing has changed by that point also, Docker is not going to do anything. If anything has changed at package.json, only then the npm install command will run. So that is the difference. If we change something in a step below, then only the commands on the top gets run, and that is where context matters. Context matter because Docker keeps context of every layer which we are building for one certain image. So if we are building This with changing package.json, the npm install command is going to run, else it is not. So npm install being a very heavy command, it talks to the internet, it picks up all the packages and dumps them and dumps them to this workdir, which is /app. So we don't want to do it every now and then. We want to do it only and only if something has changed in the package file. So if your package is changed, then only npm install is going to run. And then what we are doing is we are copying all the things from the current directory. It may override package.json as well, but no worries, it is the same file which was there previously in the directory, in the context. So no worries on this. And the next is we register this command. To contradict this, if we have this kind of scenario where we are changing maybe a JS file, let's say we went ahead and we changed a port in the startup file, which is app.js or index.js, or call it anything. We changed anything, even if we have changed the readme file, this npm install is going to get run. And this is what we don't want, because it should run in only specific cases. That means if we have some change in package.json, only then it should run. It should not run if we have changed even a bit in a readme file. Hence, the contexts are they are the root of they are the pillar of this Docker build system, and we should keep those things in mind if we want to create good Docker files. That means if you want to create Docker files in a jiffy, and we want it a less buggy in the sense of their build time, we should have those things in mind. So yeah, this is all about the Dockerfile and how Dockerfiles gets built, and what is the significance of the layered build structure in Dockerfile. Now let's move back to the Dockerfile which we have just written. So this is the Dockerfile which we have just written, and we are done with everything prima facie. Let's try building the image now. So I'm already at the directory where it should happen. Okay, so I'll just issue the build commands here. So docker build, and now I'm going to give it a context, this. If I would have a different file, let's say I would have a Docker file with name 123.txt, anything it could be, then I would have this -f flag supplied to Docker. But since I am using Dockerfile, this should work fine. The next thing is, if I create a Docker image with Docker build and then a dot, what's going to happen that it will surely create a Docker image for us, but the name of the Docker image is an auto-generated one, and hence not much readable. For this, what we do is we tag them, and when we tag them as the name and the version. Also, if you want to have multiple tags, you are free to do that as well. So if I want to have API server version 1.0, this will also work very fine. Finally, whatever is being done here, I need to give it a context. This context is the current directory where we are sitting, and I'm going to hit enter now. It should start building it. Okay, as you can see that the Docker CLI sends the build context to Docker daemon. Docker daemon actually keeps everything with it for this context, and it will keep it by the time this context stays here. So we are kind of almost done. We do not have much of the packages in there, but in the real world it is a bit more complicated when we have much more packages. There's a lot to get downloaded. So yeah, okay, so we are at final stages of the build, and yep, we have a Docker image built with us. Those things are warnings which are being thrown by the terminal at npm install to us, and it is a salient feature that if something goes as a warning, Docker CLI throws it to the std out and std error as well, standard error and standard output. Okay, so let's see what we have got here. Docker images. Fine, we have API server with tag 1.0. This is the image ID, and you can see another same image ID but with a different tag. Apart from this, we do have the node Alpine, Mongo, and software Elastic MQ, which we have used earlier. So this is the first image we have built. We are going to build two more in the same fashion in just a minute. Next, we are going to create a Dockerfile for FS frontend, which is the React app, and as it is also coming from the same build environment, the things are pretty much same, so we don't need much to write here. Just the sake of continuity, I'm going to write a Dockerfile which has got pretty much everything which we had seen earlier, and it is precisely the same which we had done earlier, so it has nothing which needs to be taken care of separately, and I shall be done with this in a minute. So we are doing same stuff, same repetitive stuff, same thing, and even same cmd. Okay, so npm what's going to change here is okay, I'm done writing the Dockerfile for the front end. So what has changed here is nothing but the directory. Apart from this, everything is almost pretty much same. So we are going to create one front end image. So same thing, build -t for tag and front end, that is, and latest. That's it. The server, the context is the current directory, and done. Yeah, so it will, you see, this time node Alpine is not being pulled off. So this is what npm install is doing for the local folder using package.json. I shall be back when it is done. Okay, so it is done, and let's see what we have here in the images section. Okay, so we have a front end as well. Let me jump to another terminal. So this is a front end latest as well. It has been created 31 seconds ago. Similarly, I'm going to create another Docker file which has no changes, and I'm gonna issue the docker build command. I'll see you just after I'm done building that as well. Just a glance of like what has been written for the polling mode. It is the exact same Dockerfile commands, instructions, which I had actually copied and pasted in here. So next I'm going to do is just this docker build stuff, the regular docker build stuff, and docker build -t, and it is the polling mode latest and the context, and we are almost there. Fine, we are done with the build. Docker images shall make us see this. Okay, polling mode latest. Okay, so we are done with the regular repetitive boring stuff. Now we are going to spin those containers to see the application in real, like happening in action. We have those images now in on our local system, and now it is the time we should start spinning a few containers. So docker run it, and we are going to expose port 3000 on the local from the container. And yep, this is pretty much what we want for the front end. So just the name front end, and this is the name of the image, docker image front end. Should you have multiple versions of your image, you can pick any of the version which you want to spin using the tag that is, let's say, latest in our case, and I'll hit enter here. Okay, so this looks good. This has got pinned up, and okay, it's running. So let's see what we have got on localhost. 3000 is what we have exposed. Okay, so this application is trying to fetch some data, but it is not available because we haven't spinned up the API server. So let's spin the other components just in a minute so that we can get some data on the front end. To spin the API server, which is our Express application, apart from the regular port opening thing, the port exposure, we need some environment variables to get passed on. So Those are the environment variables which we need. One way of doing it is I'll copy this. I'll go here. -e is the flag by which we can pass on the environment variables. I'll paste it here. I'll do this and -e. The next, I'll copy this as well. I'll paste it here and I keep doing it. Another thing which can be used as a shorthand of doing this is write all those environment variables which you need here like this and use -env -file switch and the name of this file which is in our current directory /env.list. That should work. Apart from this, API server is the name of the image which we need, and it should start working. Before I hit the enter button, let's talk about the references to other containers. So you see this API server, which is the Express application, it is going to refer SQS URL and MongoDB connection. Those things are written as localhost. So if we are developing on our local machine, localhost is what we usually write. So in this case, in this particular case, when we are spinning Docker containers, this localhost is not going to work. And there are a couple of reasons behind this. One is whenever we create a Docker container, whenever we spin up a Docker container, it actually goes to a network which is internally created by Docker for us. To see all the Docker networks, beg your pardon, Docker networks, Docker network is the command. So when you go here and you hit Docker space network, you'll find whatever you can do. So to see all those networks, we'll go and we'll do in Docker network ls. Okay. Out of those networks, we have all those containers in this bridge network, the name bridge here. So Docker network inspect and the name of the network, and you shall find the 3 containers. Those are the names and those are the IDs. So these 3 can be mapped with whatever we have in our Docker PS here. You see 59CF, 37BE, 37BE, and the another one as well. Okay, so and also you can see that it has actually created a subnet for us, and there are a few more things, but that story sometime later. When this is happening, when this Docker network thing, Docker container spin and all those things were happening, we actually provided some ports to open on our machine, which is 9324 gets exposed to 9324 of the container. So this gets exposed to 9324 of the outer world, which is 0.0.0.0. What is 0.0.0.0.0? In the world of socket programming, this thing is known as inaddr_any. That means any interface which is available, pick my port and bind it to anything which is available to outer world. So that means, what is the outer world in this specific case? The outer world is my machine. So my machine's localhost 9324, it worked. If I grab the IP of my machine, which is IP config, enter, I go here, I pick this up here, and I'll replace this, and it worked as well. Okay, so what exactly is happening? It is binding its ports, its IP addresses, exposing the ports and binding the IPs to whatever is available. So if you see, INADDR instructs listening socket to bind to all available interfaces. So this is what exactly, precisely is what is here, what is happening here. So this is as good as binding it to INADDR 0000. So hence you can see it from the local machine, but you can not see it from another container, because the local host is the container's local host, not the machine's local host. So if you go back to this SQS thing, when we spin it up, it speaks something like this as well. Okay, see here, it speaks localhost 9324. This localhost is the container's localhost, not the machine's localhost. It is opening it on this, binding it to here, and this is how it happens in the real world. So the moral of the story, when you are developing it, when you are using Docker, what you need to do is, the best bet, keep your IP address handy and drop it in wherever you want it. If you don't want to do it, what else can be done? What else can be done is create your own Docker network. When you go to Docker network, oh no, my bad for the typo. When you go to Docker network, it will give you liberty to create another one. So you can go, you can create your another network. Then when you are done with creating that network, you can pass the name of the network here, -network, name of network, and also give the container a name as well. So what's going to happen is, the next time it is going to run on a network which you have created by your own, it is going to get referred by API, and then what you can do is, you can go here and in place of this you can write it like API, and that would help. That would help in development, where you don't need to replace those stuff by the IP addresses every now and then whenever you are setting a new development environment. So yeah, this is a bit about the networking stuff and the environment variables. Since we have changed it, it should work very fine now, and it should get connected. Okay, fine. So we are connected here, and we are connected to MongoDB as well. Okay, so the seeding might have happened earlier. Okay, so this was our application. Let's see, do we have a change in here? Cool, we have a change in here. This data is coming from the MongoDB. So this is just one record which you shall get when you open this this front end after firing up the API server. There's one maybe the second last thing which is pending for now, second last component which is pending, because there's another surprising one which would come to us, a smaller one but very powerful. So the polling module is the second last one which we are going to spin up for now, and after seeing all those things have happened, and after seeing like all those things are happening, we'll jump to Docker Compose. So we'll see, we'll just spin up the polling module and then we'll jump on to the Docker Compose stuff. Okay. Next, we are going to spin the polling module, and I'm going to use the same set of switches but not the port, because it does not need it don't need any port from the outer world, because it is not exposing, it is just listening to the part where SQS ends, and it is reading and writing from MongoDB. So I'd already changed the environment list as well for the same. So this is what we are going to do, and this should be pretty much it to run the polling module. Okay, fine. So it is connected to DB, and it should be connected to the SQS as well. Fine. So just going back to the application. Now what this application is going to do is, like, I'll hit this green button which is try adding to cart. It will drop it will call an API from the API server, which is the Express application. Then it will drop a message on SQS, and this SQS is read by this polling module. Now this polling module will pick the record from MongoDB, will negate the quantity from 20 to 19, and then push it back to the MongoDB. That means it is precisely updating the number of orders. So the polling module is picking the message, negating the order, negating the count of the quantity, and updating the record. So this is what it is doing. Okay, let me click this button. Okay, so you can see that in stock count has been reduced to 19, and then to 18, and then to 17. Oh, you can see it happening here, but there are multiple consoles which are open. Like, this is the one where we are running our API server, which is the Express application. Oh, this is what we get from the front end. So we want to order my superphone, and they are 19 in stock. This is the packet which we are actually dropping to the SQS. This is being picked by the SQS reader, and yeah, SQS reader is talking to MongoDB. It is reducing the amount, and soon when it goes out of soon when it goes to 0, it will go out of stock. So you can see like 16, 15, 14, 13, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And if the next time I'm going to hit here, it is going to get, okay, this has gone out of stock now. Should you wish to see the logs, you can see them here and here as well. Also, if you want to see it in a different terminal, you can do it as well using the container IDs. So simple docker logs, container ID, drop in here, and yes, you can do it. Also, one tip here is when we do a Docker PS, then the initial 4 characters, those 4 characters are enough to do whatever you want to do with the handle. So if I want to see docker logs b2d3, it will show me the same stuff. So yeah, we are kind of done with creating the polling publisher and kind of the infrastructure which we have created. Next, we are going to introduce another thing on the canvas, which is the gateway. This is what we have done so far. So the front end and API server are exposed to the outer world on different ports. That means in real world that is analogous to different sites, maybe. If we want to unify this, what we can do is we can create a gateway on top of that, so that the user who is ultimately going to use this does not see what exactly is happening behind the scenes. So consider 3000 as a website, 5000 as a website, and 5500 as a website. So 5500.com is what user knows. So if he want to talk to the front end, he shall rather go to 5500.com, and that's it. If the user wants to access the API, he shall go to 5500.com/API, and that should be enough for him as well. So hence, this kind of gateway thing is a bit in need of the development thing, because we can actually visualize how things will look like when it is going to happen on the production. And hence the gateway thing. So we shall take care of the gateway when we are writing the Docker Compose file for this entire kind of application. So we'll start with the Docker Compose in just a second. Okay, great. So we are at the front where we shall start with Docker Compose. So I'm going to create a new folder. I'll call it Docker Compose, and I'll create a file, a YAML file in it, and the name would be Docker Compose .yaml, shorthand YAML. Enter. Every Docker file starts with a version, and this version actually tells in which Docker system we are going to feed the file. If you go back here and if you see which Docker version we have, you shall get it that okay, this is version 19.0.3. So for this version of Docker Engine, version 3.0 3.xx is compatible. So there is a compatibility list which is on the Docker portal, which single quotes, it should be single quotes. Okay, sorry, my bad. So there is a compatibility list which actually tells us about which version of Docker Engine goes hand in hand with which version of Docker Compose file. So we'll go to this browser and we'll search for Dockerfile, Docker Compose file version, and the first page probably which you will get here, this states which compose file format is aligned with which Docker Engine release. So should you have one older release, let's say you are working on a Docker engine which is 17.x, then 3.0 version 3 is not going to work. You need a compatible version, and this is what the version is all about. Whatever the version we are using keeps on updating as well, so there are like major and minor versions of this as well. So I can, if I am pretty sure what I'm going to do with it, even I can write it 3.8 as well. So but if you are not that specific, you can carry on with the version number 3 as well. Next fundamental here is services. Everything which we are writing is a service in the world of Docker Compose. So this is where we are going to write all our services, all our things which we have done in the past sections, where we have actually built the Docker images, we have used the Docker images. We are going to write all those things down here, but in the format that a Docker Compose can carry with it, can give it to the Docker CLI, Docker engine, and then it can be read and we can boot up a system on one command. We'll start writing services now, and we'll start with the easiest one, which is the message queuing server. So let's call this MQ server. And MQ server has properties as image. So the image we want to use here is software mill elastic MQ, this one. Also we need to open a few ports. So ports being a property which contains array, we write it like this. We write it ports and then a colon, and then since it is an array, so whenever we are writing arrays, we are writing it like this, preceding in hyphen, and then we write 9324 on the outer world, 9324 on my container. So yeah, we are done with MQ server. So if you see that what we have passed on the at the time when we were spinning the MQ server, we just passed two things apart from the IT flag -i -t. What we have passed was the image, the name of the image, and ports. That's it. Next we are going to write is the MongoDB and MongoDB as a service. So indentation is one thing which we need to take care of whenever we are writing a YML file. So MongoDB, call it anything, and since this thing depends on MQ server, that means we want to bring it up only when MQ server is up. So we are going to use depends on property. Since it is an array, we are going to write MQ server. Now the image what we are going to use is the image of Mongo. Mongo, that is, this is the image that will get pulled by the Docker engine. uh, all done by now. Just need volumes to mount. So volumes is the property and it is again an array. So data db on our local system is what we are mounting from Mongo data. Okay, yeah, and we opened another port here as well for this spin up container 27017 colon 27017, and that goes in a quote. Fine. Just to let you know that whenever we are bringing this whole ecosystem up, this ecosystem comes up with a name which is being given to us by uh, the Docker engine. So if you want to override this, you can leverage container name. I'm going to give it a name, container name, which is, let's say, for sake of simplicity, Mongo. All right, so far so good. We are done with Mongo as well, which is our data store, and we are going next to the API server. So let's start writing API server. Okay. So let's start from depends on. This thing depends on MQ server because we want our API server to come up only when MQ server comes up, and another service which is MongoDB. So those two services we want to come up before our API server comes up. Next, we are going to write the name of the image. Should we or should we not? If we are getting those images from Docker Hub, if those things are already there for us, what we can do is we can just write image like this, the image property. But since we are actually in the development environment, we want those things to get built before we do it, before we fork them up, before we spin the container. So what we do is we use a property which is build. Build needs some arguments over this. So one is Dockerfile. So as we have discussed it earlier as well, that you can name your Dockerfile anything. So for this API server, we are going to refer this Dockerfile. Should you have another version of your Dockerfile for your development environment? So you can create a Dockerfile with say name dockerfile.dev, and you can mention it as dockerfile.dev. You can mention it like this as well. So should you have multiple versions of your settings, so this is how you can do it. You can segregate them, you can isolate them, one for the whatsoever build and one for the build which is happening on your development environment, and so on. So this is how you can do it. So hence the name of the file matters if you have multiple environments, if you need to carry multiple environments. For now, let's go back, rename it to the default name of the Dockerfile, which is Dockerfile, and change the same here. Okay, Dockerfile and context. So context would be one level down, and then fs express hyphen pi. Okay, fine. So the context here, one level down. Why this? Because our Docker Compose is running from a directory which is here on the level of fs express. So to access this, what I need to do is, like, I need to go to the root, and then I need to go to fs express, and that would be my context. Okay, so far so good. We are done with the build and all those things. What else we need here? We need environment variables and ports. So let's do the environment variable thing real quick. Environment. Okay, we can pass environment variables in env file, and we can do it in by using environment. So when you are writing a Docker file, and if you do not want to switch between multiple files, and if you have like the number of environment variables are like lesser, so that you don't need to scroll them, I would suggest that you pick your environment list from here and copy everything, and then you paste it here like this as well. This should work. Also, this is an array again. So what we are going to do here is, like, we are going to indent this. We are going to indent this as an array. Fine. What else we need? We need ports. We need ports. Thanks to the IDE. And 5000. Okay, all right. We are done with the API server. We need polling mode now as a service. Polling mode needs to go to this level. Wrong indentation. Now it is correct. Okay, so polling mode, and we'll just start with polling mode as well on the same lines. Is this thing also need MQ server? This thing also need Mongo DB. Okay, and the build. Okay, Dockerfile is our Dockerfile. Quickly, the context here would be one level down, and polling -mod. Okay, I can, for clarity, we should actually write it like this. Okay, so yeah, that is the Dockerfile and context for polling mode. What else we need here is the environment variables. Environment variables from env.list. We're going to copy this. We are going to paste them in here in environment, and here a little bit of indentation, very quick, and array. Cool. So we are kind of done with the polling mode and the API server. There is something called a restart policy, which I want you to take in your consideration. So if you want your container to get restarted on failures, you can write it like on failure. If you want to restart it always, you can write always in here. So since we are writing it for our development environment, we may or may not need this depending on what is the level of debugging what you are doing. This can be modified. So for now, like I'm writing it restart always. Okay, one more thing before we continue on this for our front end, that is that those references to other services. Previously what we did is like we actually replaced it the local host with our the name of the IP of the system of the machine on which I am working. Since we are using Docker Compose, so what Docker Compose is going to do, it is going to create a network for us. So in that case, the services shall be referred by their name. So MQ server is the name of the message queuing service and the message queuing service. Same goes here. Since now we have actually overridden the container name with Mongo, so Mongo is what a name which is being kept by the DNS records of the Docker network. Hence we are going to use the name Mongo, and we are going to replace it on the same lines, Mongo and Mongo. Okay, good. Oh yeah, we are kind of done with this part as well. Polling module does not need any ports because it never talks to the outer world. Next would be the front end, and we shall start with front end on the indentation level of the service front end. Whenever you are writing a YAML, please take care of whatever you are writing, because if you are not using a very intelligent IDE, there are chances that you may keep misspelling something over and over again. So yeah, back to business build. Dockerfile context, one level down, fs-front end. This is the context, and then comes, okay, what I did wrong. Okay, so I did it all wrong in here. It should be like this: Dockerfile and context indented inside the build. Yeah, next would be do we need volumes? We need ports. And that is the port 3000 on my internal machine, 3000 here. Okay, so we are done with the front end as well. Next we are going to start with the gateway. So we shall do a bit of the configuration of the gateway, a bit of scratching the surface of Nginx, and then we'll write a Docker file for the gateway, and we'll come back here and we'll write a lean configuration for that Docker file as well. So yeah, this is what we have for all the components which we have till now. So let's get started with Nginx. Nginx is an API gateway, a web server, a reverse proxy, a streaming gateway, and whatsoever. So Nginx is used widely, very widely nowadays in while we are actually deploying things. So Why we need this in this example? Because we just want to expose just one port to the user, so everything else should become a gray box to the user, and this is how it happens in the real world as well. Let's get started with writing a lean configuration of Nginx, and then we shall write a Docker file as well for Nginx. Back in the coding window, I would start with a new folder. Let's name it GW Nginx, and okay, Nginx, and configuration is all we are going to have it here. Okay, cool. And this, let's create a configuration file and let's name it nginx.conf or whatever you want it to. Okay, now this something called an upstream in Nginx while we are writing when we are writing a configuration for Nginx. So we are going to upstream to front end, which is the name of our service, and we are going to use the server front end on the port 3000. So this is what we did when we have created front end on port 3000. Next, in Nginx we are going to create another thing which we want to, another upstream which we want to expose, which is API server on port 5000. Cool. Okay, next the real stuff happens here, which is the server configuration. We want our Nginx to listen on port 80, but we are going to expose the port 80 with some other port. The plan says to open it on 5500. Now let's part the incoming requests. So in this part we are going to write where we need to pass the requests in certain forms. So if we are getting a request which is asking us to access location root, we are going to pass this to the front end, and we have already created a upstream on this. So one done. The next is location/API, and we are going to proxy pass this to API server, and this should be API server. We have already created an upstream for this as well. Since every call to our API server, which is this API server, starts with an API, you can see that API hello, API try add to cart, API get items fs. Hence the prefixes to your routes are very important when you are developing. So whenever you are developing, please keep that in mind, because that is going to ultimately being used when we are actually creating a routing configuration. When we are creating an API gateway. So yeah, we are kind of done with the configuration which we want to write. Now what we are going to do here is we are going to write one Dockerfile, and that Dockerfile would be taking Nginx as a base image. So when we are going to write this, we are going to pull Nginx as our base image. So just quickly start writing a Docker file for the same. My bad, Docker file. Cool. Okay, so same stuff from Nginx, and what we are going to do here is very simple. We are going to copy our nginx.conf from the current directory to /etc/n, my bad, oops, nginx.conf.d, and we are going to write down default.conf. We are going to copy it as default.conf on etc nginx.conf.d. This is it. So we are done writing our Docker file as well for Nginx. Next, we are going to have this Docker file in our Docker Compose. So that is probably the last thing pending on Docker Compose. So let's do it real quick. Okay. Indentation for the gateway. This gateway depends on front end. Front end should go up. So this is how we can actually identify whether our gateway is working or not. At least one service we need. So for the sake of simplicity, I wrote gateway here, and a restart policy, which is always, so your gateway should always be working. Oops, what I did wrong. Okay, the policy should go like this. And what next? We need obviously the build configuration, and that would be the Dockerfile, which is our Dockerfile, and the context to this would be the gateway Nginx configuration. Good. Finally, we need to expose port 80, and the plans are to open port 5500 from the containers 80 port, because container, the Nginx shall be listening to it on port 80. Fine. Okay, so we are kind of done with the entire Docker Compose YAML, and yeah, now let's try spinning it and let's see what happens. So first we'll build, and then we'll spin the Docker Compose. But before this, let me clean the slate what we have in here. So this Visual Studio Code, those guys have like very good plugin. This is the Docker plugin, so if you want to use it, you can use it, and if not, then you may continue with the Docker commands, which remember. So let's first go and start cleaning the slate. Okay, cool. So I'll start from Docker PS. Okay, all those processes are running, so I'll just go write Docker PS and -q, and what this is doing is it is returning me the container ID. So what I'm going to do here is I'm going to use this as a shorthand to stop all those Docker containers. So I can do it Docker stop using Docker stop and writing all those things manually, 580e f9cf, but that would be very tedious. Being a lazy developer, I am going to use docker ps-q and I'm going to stop them all. Okay, they are all stopped. I'll go to docker ps. I'll find nothing in here. Cool. But there could be something which is halted there. So those things have exited, but they are still halted. So we need to clean this up. Docker rm is the command, and here I'm going to do same thing, kind of ps-a-q. It will give me the IDs of all those containers which have exited, and docker ps-a shall return me nothing. Very good. Now docker images. Okay, we have so many images. Docker images-q. Let's see what it returns. All good. So we are going to use docker rmi $docker images-q on the same front, parenthesis closed, and remove all the images. So we have a clean slate. We have nothing working. We have all those stuff halted. This has gone. Okay, and what was there else? Okay, this is also done, gone, halted. So we do not have anything running here. We have everything stopped, and okay, we have got an error. Docker images. Okay, we do have some images still there. Okay, that is good. So why we have that error? Because this image is being tagged twice, and since we have been using an API latest and what API 1.0, API server 1.0, then we need to do it manually. So I'm going to do docker rmi API server latest. It has untagged it. What I'm going to do next is I'm going to untag the second one as well. And when I do an untag on the second one, this actually removes it. So let me go docker images once again. Fine, we have just one there. So docker rmi node alpine, and we have a clean slate now. Docker images done. Okay, so let me clear the clutter from here, and I shall be back with the docker compose part in a moment. We'll start with docker compose now, and docker compose build is what I'm going to issue to it. And what it will do is, like, it will pull all those images which are there needed in docker compose build. That means all those which are readily available, which are written as image in docker compose, that are not going to pull. So it has skipped MQ server and MongoDB as well. So it by the time it ends, it will what we will have in images is the base images and the images Docker Compose has built successfully. It is going to take some time, so I'll just pause this and I'll come back when this build is done, because it is going to throw some scary red and blue lines as well. So just let me pause this video real quick and I shall be back when it is done. Okay, so the build is done now, and let's see what we have in images. Okay, as you see that the gateway, GW, front end, polling mode, API server are preceded with Docker-compose. So yeah, this is what we have as in for the repository, and those are the image IDs. Apart from this, let's concentrate on those two. Those two are just the only two images which we needed as a base image. So Mongo and ElasticMQ are still to get pulled by the Docker engine, and this will happen when we are going to issue the command docker compose up. Now quickly let's issue docker compose up and see what happens. Okay, so you see that it is creating a network docker compose _ default, and also it has started pulling ElasticMQ because that is being needed by MQ server, and it was there. We actually mentioned it in image, so it has actually started pulling it from the container repository. So it is a bit bulkier, so I'll be back when it is done. It is done with this ElasticMQ, and now pulling Mongo from the repository. You can see it here, pulling from library Mongo. Again, let me pause the video and I shall be back when the pulling of Mongo is done. Okay, so it is done now, and we are API server is coming up. You can see that a few times this polling mod and the API server have failed to bring themselves up, but as we had a restart policy, so they went up. Why did that happen? That happened because polling mode depends on MQ server. So MQ server was not up by the time the polling mode was up. Why did that happen? Because Docker only takes guarantee of the container and not the service itself. So when we are talking about service to come up, we can, if you want to have a check like the service we depend on, is that up, we can actually write health checks in the Docker Compose. That story some other time. For now, we are concerned about the restart policies. So restart policies worked, and what depends on is not doing for us is it is not doing a health check on the service. Let's quickly go here and okay, so the hello world is working for us. So our APIs are working, and the front end now. Okay, we have a bad gateway. And why do we have a bad gateway here? We have a bad gateway because this application is not working anymore. Docker Compose front end has exited with code 0. Even if you have a restart policy there, it will keep continuing exiting. And why this would happen? Because the node application which we have, it need to stick to some place, and that would be the standard input. Whenever we open a terminal and we issue the docker run command on front end, it actually starts the development server, and it waits for some input. So that thing is known as std-in. So this is a kind of hack which we are going to apply here, and this is known as std-in open, and we shall keep it open for our front end. We'll go back quickly and we'll stop it pressing Ctrl C, and we will bring the ecosystem down. Okay, before we do it, docker ps is what you should see, and docker ps-a is what you should see. So we do not have anything working in docker ps, but when I issued docker ps-a, it showed me like those are the command which were exited. Those were the containers, I beg your pardon, those were the containers which are not working anymore. And as soon as I issue docker compose down, I won't see any container now working here, docker ps-a. Now since we have actually changed it front end, the configuration here, std-in open, so see, we haven't changed anything in the build, so we are not going to build it again. What we are going to do here is we are going to just docker-compose up, and I'll press enter. A shorthand to this situation would be docker compose down, and after this I'll write front end, and then docker compose up space front end. Front end is the name of the service. Previously what we had seen was that it exited. Now it stays there, it is waiting for something. So this is what we wanted to achieve using std-in open, and this is what we have achieved. Let's go back and hit a refresh, and you can see that it is loading, and all those logs would get logged here. So you can see that API servers logs are here, polling modes logs here, and all those logs which you had to see previously, and you need to switch between multiple terminals. Now that thing is also a bit eased off. Finally, Docker network. Docker network ls. Docker compose default is what it has built for us. So we will just inspect this. Docker compose underscore default, and what happened? Docker network inspect again. Now you can see that all those containers which are working, and you can see the name is Mongo and not MongoDB, and hence this is what we have achieved by far what we have done is we composed everything into one file, and this is how we can actually use Docker Compose in an environment which is, though a development environment, but it is more close to the production environment. Hence, so this was the all sum up of all that exercise which we did in last couple of hours, and this is what we wanted to achieve. And we have a running application which has got kind of 6 components working together to make it happen. Okay, I'm just making it out of stock. Sold. Okay guys, so this is it from the Docker Compose side. So this actually scratches a bit of the surface of Docker Compose, how to use it, how environment variables work, networking, a bit of networking on Docker Compose as well, how Docker engine works. In case if you have any questions and any comments on the content, please let us know. Drop your comment and we shall be happy to come back. Yeah, thank you so much for watching.